Today we will learn the concepts on oscillation. Under this topic, first we will discuss about simple harmonic motion and get equation for displacement, velocity and acceleration, and then we will discuss the oscillation of simple pendulum, oscillation of springs, oscillation of other systems, and then about the total energy of simple harmonic motion. First, let us know what is meant by simple harmonic motion. It is a periodic motion. What is meant by periodic motion? Periodic motion means a motion which repeats itself at regular interval. A motion which repeats itself at regular interval. Periodic motion. Now, if a particle starts from the mean position, goes to one extreme, say A on this side, then comes back, goes to opposite extreme B, and then goes back again to the mean position, such that if x is the displacement, instantaneous position, let us take as P, and this is x, at this position P, it always experiences a force in opposite direction. In opposite direction proportional to the displacement. So there is a force on this particle, and this is the direction of displacement, and this is the directed. The force is always directed towards the mean position. This is the proportionality constant. K is called as the force constant. So if the particle is under such force, which is called as the restoring force, this is called as the restoring force, then it is said to execute SHM. So simple harmonic motion can be defined as a to and fro motion about the mean position, such that the force and hence acceleration of the particle is always opposite to the displacement and directed towards the fixed point, which is called as the mean position. Such a motion is known as simple harmonic motion. It is a periodic motion. Simple harmonic motion is periodic, whereas all periodic motion need not be simple harmonic. For example, heartbeat is a periodic motion, but it is not simple harmonic. So this is the definition for simple harmonic motion. Okay. Now let us get an equation for simple harmonic motion. Can be obtained from considering SHM as the projection of circular motion on the diameter of the circle. So suppose you have a circle A dash and B dash are the diameter, which you consider as the x-axis, and this you can consider as the y-axis. Now you take a particle starting from A and going here, performing a uniform circular motion with angular speed omega. What is omega? Omega is the angular speed or angular velocity. Omega equal to theta by t. Let after some time it goes to the position P. From P you draw two perpendiculars, M to the x-axis, N to the y-axis. So consider a particle performing uniform circular motion on a circle of radius A. Let us take this as A. Okay, or we can take as capital A, because we will be having acceleration also mentioned here. So we will take it as capital A, the amplitude, radius equal to A. Okay. Now when the particle reaches the position P, you draw the perpendicular to the x-axis. The foot of the perpendicular is M, foot of the perpendicular on the y-axis is N. This angle is theta. When the particle completes one revolution, if you watch the foot of the perpendicular, it will complete one oscillation. So starting from here, N is here, it is going up and then coming down and then going down and coming to the mean position when the particle has completed one revolution. So we can consider SHM as the projection of circular motion on the diameter of the circle. Okay, now let us write equation for the displacement x and y. This is being A. So, x is equal to, using the triangle OPM, x is equal to A cos theta, or x is equal to A cos omega t, y equal to A sin omega t. So, both are equivalent representation for the displacement. You can use either cos omega t or sin omega t. Okay. Now, suppose the particle is not starting from mean position, but it is already at some angle when it is starting. Okay. So, let us take like this. Already this angle phi, the particle is at say this is q, starting from q, then it is going to p in time t, this is theta. Then now if you draw the two perpendiculars, x will become A cos theta plus phi, which can be written as A cos omega t plus phi. Similarly, y will become A sin omega t plus phi. Then phi is known as the initial phase. So, this is the general equation for the displacement. Okay. Now, we will define certain terms with respect to SHM. We will define amplitude. Amplitude of SHM is defined as the maximum displacement. Maximum displacement. So, if the particle executes SHM and goes to this position P and here Q, then this is A, amplitude, maximum displacement. Then time period T. Time period T is the time taken for one complete oscillation. Time period T is the time taken for one complete oscillation. Then relation between omega and t, omega equal to 2 pi by t or 2 pi n, where n is number of oscillation per second or frequency of oscillation. N is number of oscillation per second or frequency of oscillation. Okay. Now, let us take one of the form for the instantaneous displacement of the particle, either x or y. From that we will get the formula for velocity and acceleration. So, y equal to A sin omega t. Dy by dt is the velocity. So, differentiate here, you get A omega cos omega t. V maximum, which is called as the velocity amplitude. V maximum is called velocity amplitude, and V maximum equal to A omega. V maximum is equal to A omega. Also, we can write V as cos omega t is 1 minus sin square omega t. We can take this A inside and it will become root of A square minus y square in terms of the displacement. So, you take A inside, it is A square, this is A square sin square omega t, which is y square. So, if they give displacement, you have to use this formula for finding the velocity at any point. Next, we will find expression for acceleration. differentiate equation 2 with respect to time, we will get the acceleration d square y by dt square can represent by small a minus a omega square sin omega t, which can be written as minus omega square y. This is equation 5 and 6. Minus omega squared y using this. What is A maximum? A maximum is called acceleration amplitude. And from this expression, A max is equal to A omega square. A max is equal to A omega square. If you want to show any motion as simple harmonic, if you want to prove it is simple harmonic, you must get an expression for the acceleration, and it should be in this form. It should be having negative sign indicating opposite to the displacement. Acceleration proportional to the displacement in opposite direction. That is the form in which we should bring. Okay, and the proportionality constant is the omega square. Proportionality constant is omega square. Okay, now we can get the expression for the restoring force from 6. Multiply both sides from by m, you get ma, which is the force, minus m omega square y, or F is equal to minus ky. So k equal to m omega square. Comparing. So these are the equations you have to use regarding the displacement, velocity, acceleration for SHM.